your day has been. The beauty of setting sun will make everything serene. To pray rightly, you must make God your hope, stay, and all. Right prayers is nothing substantial or worth being concerned about except God. I invite Faiz Ryan of first year MCA to recite GOKILA.
Thank you, Ma. Thank you. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. Amen.
Thank you, Faiz Ryan. On behalf of the MCA department, we are pleased to welcome one and all gathered here. I request Sati to welcome the guest and introduce her to us.
Yeah. Good evening, everyone gathered here. A warm welcome to everyone to this evening. I am extremely overheard to get this opportunity to address you all on this webinar. On behalf of the Institute, I welcome our chief guest, Mr. Dr. S. GOKILA. She is working as Associate Professor in Computer Application and ODL Programme Coordinator, MCA in Hindustan Institute of Technology and Science. She has over 13 plus years of teaching experience. She has completed Ph.D. from Bharatiyar University, Coimbatore. She also cleared UGC NET exam. She completed M.Phil from Periyar University, Salem. She published four books like Advanced Java Programming, Visual Basic for Self-Learners, Problem Solving Using Python, and Python Programming Theory and Practical. She also published 15 journals. She did 15 more conference presentations. She also did 25 plus workshops and seminars. She also a guest lecturer in 10 colleges. She is member of professional bodies like Lifetime Member in Computer Society of India, member in International Association of Academic plus Corporate Society, and members in Association of Computing Machinery. Her academic activities include reviewer in International Conference on Distributed Computing and Electrical and Electronics in Bellary Institute of Technology Management, Bangalore. Reviewer in International Conference on Mobile Network and Wireless Communication in Sri Siddhartha Institute of Technology, Bangalore. Reviewer in IEEE Mysore Subsection International Conference in NAVKIS College of Engineering, Mysore. Advisory Committee member in International Conference on Computational Intelligence and Communication in Presidency College, Bangalore. A reviewer in National Conference on Future Perspective for Basic Science in Vinayaka Mission Research Foundation, Chennai. Reviewer in VRI publication, revised paper in International Journals of Engineering and Technologies. Examiner in autonomous colleges. She also translated 13.25 hours of SWAYAM NPTEL course in software engineering offered by IIT Kharagpur into Tamil language. We truly looking forward to your session, ma'am. I also extend a hearty welcome to all the participants, and once again, welcome, ma'am. Thank you, Mataji.
Thank you, Sati, for the welcome and detailed introduction. The capacity to learn is the gift. The ability to learn is the skill. The willingness to learn is a choice. There is no elevator to success. You have to take these steps to help us achieving in success. Here we have Dr. S. GOKILA, ma'am, all ready to take over the session on the topic Big Data and Hadoop framework. Learning begins with listening. Let us all lend our ears to widen our knowledge. Please, ma'am.
Thank you, Matangi. I thank the organizers and the head of the department and the management for inviting me and giving me the opportunity to present and share my knowledge all among the students. I thank all the participants, those who joined over here, because even after the college over, you people are having a thirsty of knowledge to get some information about the technology. I'm so happy about it. Let me straight away go with the session by sharing my screen. Screen is visible to you all. Can anyone please confirm?
Yeah, ma'am.
Yes, thank you. On this, we are going to get into what is big data and the framework which is supporting to handle that. The world is revealing around the data. Without data, we cannot speak anything. Usually, we have that whatever we talk, we have to have an evidence. Based on that only, we can prove anything. So whatever the prediction we are going to do, the world is in a competitive. If they want to upgrade to their level, any domain, the business domain or an education domain or even the household, everything how to have a decision based on the past history. When we take a past history, that contains volumes and volumes of data, because we cannot do any prediction with the minimal set of data. When you take a climate, because that is a challenging one, when we take that particular domain, the prediction is based on many mathematical model. They have a criteria that minimum of 30 years of data should be taken in order to run that model, in order to have the prediction. Beyond to that also we have to have, because it is having more and more fluctuation. So in order to study that, we have to have a volume of data to do that. It is true for all the many of the domain. If they want to start up a business, if they want to do any decision or any prediction, they have to reveal on a data. When we are looking into that, we'll be having lots of information, but we may not have that as a single platform, and we cannot do the analysis just by looking into that. We cannot have a decision on it. So we have to have a procedural, systematic and engineering aspect of steps to handle those information. So for that, this particular session will be giving you the idea about it. So before starting off it, I want to know how many of you know what is big data? Can you all raise your hands for it? Let it be an interactive session, okay? It should not be a one-way communication. How many of you know, or how many of you have a bit idea about big data? Please raise your hands. Yes, or else you can put in chat also, whichever is convenient to you. I got one response. Organizers, can you please confirm whether the participant having an access to do that access feature, like accessing the chat and using that annotation options and all? Do they have the facility?
Yes, ma'am. They are having access.
Thank you. Then participant, you can give your response. How many of you know what is big data? How many of you having a bit idea about it? I got only one response. Others? Yes, Fires. Yes, Arun Kumar, thank you. Yes. Yes. Okay, some of you know about it, some of you might not. Okay, very good. Thank you for your response. So in this, we are going to start from base, because only the 50 from the response, I could able to analyze that for 50% of you know, 50% you are not having an idea about it. Let us start with what it is, and we gradually increase how the technology can be incorporated into to deal with this huge volume of data. The first and foremost, when we talk about big data, it always talks about volume of data. We talk about six V's. The first one is the volume of data. It is a huge set of data. It is going to be in a form of terabyte, zettabyte, and petabyte. That much volume of data involved. If the data size is that much, we call it as a huge volume of data. So the big data is a huge volume of data. That's the first one. And the second one is the variety of data. When we take an information, even if you take information related to one particular field, we'll be getting many variety of information about that. It is not a unique set of information. Everything will not be have a uniformity also. Even you take that, if I want to have an analysis about the student performance, the information which is being maintained may be in a different form. So that may be the variety of information you may be getting. And the growth of data, because if I'm going to analyze about, let me take an example of that, how many of you watch the latest movie? If I'm taking the review or analysis about that, if I'm taking that analysis on today, from the past history, I may be revealing with, or I may can have a prediction on that. But if I do the same analysis on tomorrow, I definitely I will be having some more information about it, because when the days goes on, the information also getting gradually increased. So the volume of data is being increased day by day. Let me take an Amazon analysis. If I want to if I want to do the analysis of the review of any particular product, the some of the product might be having a set of review today. If any offer is being happen on this shopping platform today, if I take a review tomorrow, definitely I will be having some more information about that. Some more information also, it is not in a gradual growth, that may go in fast development. The day by day set of data on the net is keep on increasing, keep on growing. So that is why it is a velocical based also. And veracity. And when we take the huge volume of variety of data which is being growing day by day, we have to think of the trueness of that, how far it is correct. Whatever the data we are taking, whether it is correct data or not, we are collecting this, there, all that data I'm having in my hand. But before start doing any of the analysis with the correct set of data, I have to ensure that veracity of data, how far the data is correct. And that next one is the value. And even though if I'm having a value, whether that particular value is suitable to that particular analysis or not, whether that is related to that or not, that we have to filterize. Is it exact to place on that? This value is right value or not? That have to be identified. And variability. If you take every set of value, when it is growing, even in the growth, the fluctuation may be different. For example, if I'm going to take any data sales report, this is an example I'm taking because this is the one everyone can understand, because everyone doing some purchase in online, everyone, even on a shop also we are doing it. One particular product may have a sales report gradually. On particular day, it may have a huge sales, or it may be in a particular day, it may be with a very less sales. So that will the fluctuation of the data will be more. In one particular day, the fluctuation will be more. The other day, it will be gradual like that. So all that have to be put together in a consideration when you are taking that a huge volume of data. The volume of data may be having a very multiple variety. That volume of data may grow fast, that may be correct, it may be having a wrong value, and the graduation of that value, that is the growth of that value, and the axis and the scale of the value will be having more fluctuation on. Okay. When you take an analysis about the traffic data I want to analyze, if I want to analyze the traffic data of particular day, definitely if I take the one particular signal, I'm capturing images, I'm capturing more number of images on one particular signal, I want to analyze how much ever the traffic is going to happen on that particular day. There also it will be going to the volume of data in a size, it is going to be in a terabyte or petabyte, because everywhere we are capturing the sequence of video through web camera like that. When you look into that, that is the traffic signal, all that. When you take the images from that particular sequence of videos, on one particular time, we'll be having a more number of images. So that the variability is more in that particular sequence itself. So likewise, the volume of data will be having variability. When you put all that together, that is what your big data is. Big data is going to have all these characteristics. In the size, in a variety, in a value, in its trueness, and its fluctuation, all that. Why we need it? why I want to have this big data. When we are talking about that big data, this big data handling is required because of the nature and the structure of data. The first one, we take it as a structured data. When you look into that picture, what can you observe in it? Can anyone give a response?
Ma'am, I think the squares are arranged, ma'am. First, I can see the blue, then I can see dark green, then I can see dark blue, then I can see dark green. It's arranged, ma'am.
Yes, it is arranged. So I can clearly say that the first row is a dark green, second row is a blue, light green. Like that, I can predict it. So even if I take in a column, one after the other, so it can be identified easily by identifying. If I look into the particular cell, I can predict what value exists in that. So if I'm able to do that particular analysis, if I'm able to capture a data on a particular in a direct way, then we can say it is a structured data. As you all, most of you all in a computer science field, I suppose. So I can give an example of this structured data which is going to be in a database. So there we'll be having the information in a row and column wise order. We can send a query or we can identify a particular row to pick a value. The column name we be having. So if the value are arranged in a proper manner, then it is said to be a structured data. So when you're even a big data can be structured also. So if this is the case, it is easy to access. But in a real environment, we may be having other two structures also. This is said to be a unstructured, or you can say it is a semi-structure. By looking into that, we can say that this much of variety of data exists in it. But I may not predict which varieties exist in which particular location. The variety I can identify, but I may not say which variety is existing in which particular column or cell. So this particular one is unstructured or semi-structured. And the third possibility that is, this is also somewhat related to that. The previous case, when you take it as a unstructured, it is completely of messy, like what we are doing with the text notepad and all. So if it is somewhat arranged like this, the semi-structured one, this we can compare with the HTML data. We'll be having a tag to identify some text. So somehow I can pick it, but I may not pick it exactly. So that is going to be in a semi-structure. So whatever the set of data you are taking out, those particular data may fall on any of the structure possibility in any of this arrangement. All that have to be taken care, because when we are saying we are going to be collecting, right, the volume of data will be in a variety of format. So that variety can have different structures like this. So when you are taking a volume of data, we may not have a prediction that all that data is going to have a uniform heading. All the data, what I'm going to take it as having a same uniform header on it. Let me take an example that I want to have an analysis about two different colleges. I want to compare the performance of, as I'm running an university, let me take a Madras University itself. If the university want to have the analysis of the students' performance of two different colleges, the internal examination, don't consider about the final examination. Okay, the internal examination. The college one may follow the different heading name. The roll number can be mentioned as a register number in that college. The other college may be specifying that is a unique number. There, the column name itself different, but when I am getting into the data, I will be coming to know that this is mentioning about the unique identification number of the student, but the heading may different. And here, one college one may be following two different assessment technologies, like they may be giving an assignment, they may be conducting 3 internal assessment and 2 model exams. And when you take other college, they may be conducting only 1 assessment and 1 model exam. So the different structure will be followed by 2 different colleges. When the university is taking that, even though that 2 data are independently structured, when I'm going to combine that two, that is going to become a semi-structured order. Because I know that this data exists, but I may not know where exactly it is, under which particular column my required data exists. So when I'm talking, because the big data is going to be like that, we are going to collect information from different places and I'm going to have a single point of analysis. In such case, all that volume of data may be in a variety, that variety may have into the different structure. Can you people give me some example of this real-time data where we'll be having that unstructured big volume of data or structured big volume of data or semi-structured one? Speaking now. Some real-time example where we'll be having that high volume of unstructured, semi-structured data. Whether it is right or wrong, give your input. I'm getting it in chat, I suppose. Weather application, Google. I'm not saying about the application. I'm talking about the data set. What do you mean by that Google, Syed? You are saying it is a Google, right? What do you mean from that? It has images, videos. That is a variety, yes. A variety of information exists. Can you give one exact example about the unstructured data in a net? Unstructured data in a net. Yes, file management. Yes, file. That is, the file management is different. The content, what you are having within a plain notepad, that is completely about unstructured. Let me give one real-time example that I like to do one analysis about the review comment given for a particular product. If I'm taking all that review, will that be in a structured format or unstructured format or semi-structured format? In which category that review content will fall on? Unstructured, this is the one response I got from Shagir. Audio and video can be unstructured, yes, of course. Audio, video files come into the unstructured. And when you take a review comments, that is going to be in unstructured, of course, because we may not, that is going to be completely in a one file. We cannot identify which review has been given. If we are having that data in a row and column wise order, then we can say which review has been given by whom, all that. If you take only that review text alone, the person one has given this comment, person two has given this comment, because they are giving it in a natural language, that is going to be in unstructured one. All the online comments, yes, all the online comments are going to be in an unstructured manner. If you take that, is when you take all that review comments, that is going to be in a completely unstructured. There also we are having a huge volume of data. If Amazon want to analyze the review comments of their customer, when they are taking that data, the complete data is going to be in unstructured. So how can I handle all that? But because by keeping that unstructured data, I may not do all the analysis. Some of the unstructured data can be handled. If I'm going to take an audio file and a video file, I can have a coding to chunk those audio files. And sometimes I can, if I'm taking the video file, I can split the track of audio, video, all that. Then I can chunk that files into multiple parts and I can do the review. But in some cases, I have to have that complete unstructured data as a single unit and I have to work on that. How this platform, the Hadoop and all, giving you the support for it. That's what we are going to add. Before getting into that, we have to know what is the challenge exists when we are having that complete set of unstructured, semi-structured, high volume of data. That we cannot have it in a single place, because as it is of terabyte, zettabyte, and a petabyte of data, we may not have that in a single storage place. We have to have a distributed storage. Okay. So in the case of distributed storage, as an individual, I may not be able to go and buy, or I cannot take simply any cloud storage. Simply, I cannot pay and get it. Okay. So with a single unit itself, we can work on that, for which the Hadoop is going to support. And when it is going to be in a processing, with that data, I'm going to do some analysis. As I said, I want to analyze the review of a particular product which has been given for an Amazon product. So it will be a huge volume of data. By handling all the data in a single place with a single central processing unit is going to be a very tedious process. In such case, I can work on a parallel processing. Have you all have an idea about the parallel processing? What is the parallel processing? Clone which work as a copy to do the multiple task. Actually, the multiple task in the sense, even in a single processor, we can do the multiple tasks. But here we'll be having a different number of processor itself. I'll be giving your data to you, you will be working on it. I will be giving us another set of data to another system that will work on it. So the processor, there will be a more than one processors itself. If I'm running any of the program in my system, only one processing unit is there. I'm having only one CPU that is going to work on that. But when it is going to be in a parallel processing, we'll be having a multiple number of processes. I will be having a multiple central processing units itself. So I can divide my data, because instead of having a single storage, I'm having a data in a distributed location. Then and there in that location itself, I can do some coding, I can execute that coding, I can get a result. Similarly, in a second place, there is a data, that data can be processed, I can get a result from that. So my work is being splitted among more than one people. For example, let me give you another one. I have been given an imposition to write one particular algorithm for 10 times. But I'm so lazy. I'm giving that to my, I'm taking that to, and I like to get a help from my sibling or from my mother or somebody in my family. What will you do? What will you do in such case? I have to complete writing an algorithm for 10 times. But I don't like to do by myself as an individual. I like to get a help from my family. What will you do? Please forget about the handwriting and all that, okay? Let me take that, I have to type and submit it. Yes, split the work. Okay, if I'm having my brother or my sister, I will be pleasing them to write for 2 times. I will be pleasing my brother to type it for 2 times. I will be pleasing my mother to do it for 2 times. So my work is getting splitted. I have to collect it back, everything. I have to collect all that everything, and I have to arrange in a proper order, and I have to submit it. So that is the one, because the multiple task only, but the task is not being done on a single place. The task is being done on different places. So that is what the parallel processing is. And when you are having that arrangement of the distributed, and we have to have a systematic storage for that particular data, and we have to have a proper platform to distribute that work also. This particular data have been applied on this particular process. I'm having a data, what analysis I have to do, what is the result I have to take from there, or the same task how to be done on different data, because the writing of an algorithm is a task. This has been completed by my brother, my sister, and my mother. The same task is being done on 3 different places. So all that have to be monitored centralized way. So for which the Hadoop is going to support for us. What are the data? I'm going to give it to that. What are the process have to be taken place on that particular data? And there is a centralized unit going to monitor all that, where all these data exist, which data is being applied on which particular process. All that have to be monitored in the centralized, and all that have to be controlled centralized, all that have to be distributed centralized. That is, from one central place, it has to be distributed to all other places. Then only we can take everything back. So for which the Hadoop is supporting. Rahul, what do you mean from that no use? I didn't get from your response. Okay. Whatever maybe the data is, whether we're unstructured or it may be a semi-structured, all that have to be distributed, all that have to be processed parallelly with the help of an Hadoop. But it has to go with some cycle in order to handle that in a proper way. Because when we are talking with the volume of data with a multiple variety, and we have to identify its trueness also, for which we have to have some systematic procedure. This procedure, it is not only to the big data, even to the small volume of data also we have to do this cycle. Then you can have the proper flow and handleable data in your hand to complete the process. Okay, the first one is this entire cycle is going to have applicable to the all set of domain, whatever the data it is going to belong, whether it may be a review data, or it may be a weather data, or it may be a sales data, or it may be some prediction oriented, or it may be a result analysis oriented one, or it may be a DNA analysis, or if I'm going to take care of an analysis of any audio file, how far this pitches exist in, for example, I want to have an analysis that how much ever the pitch variation is being applied in the Ilayaraja song. So I have to take all that Ilayaraja song and I have to track that audio and I have to analyze all that. So in whatever maybe the domain is, the volume of data is going to be huge. So for all that domain, this particular cycle is going to be applicable. Okay? Irrespective of the domain of the data, we have to do this. The first and foremost one is the data acquisition. We have to find the right place to collect that data. You can take this as a research perspective. I noticed from your login screen that most of you are from IT or CSE or MCA department of students. You may have to take up your final semester projects, and later on you have to concentrate on your research also. In that case, when you fix on particular field of research, first thing you have to think about where do I have to get that data, where I have to collect those relevant data. So identify that sources and you take all that. By looking into that data, you can able to identify that uniformity of data. The same data, as I told in that the result analysis of two different colleges, they may be having the information but in a different form. So how to manage all that? So first we have to acquire the data, gather it. It may be a structure. One may be for maintaining the same set of data in a structured format. Other may be maintaining it in a semi-structured format. You collect all that, and later on, in using all the other steps, we'll be going to make it as a uniform and structured and processable one. Okay. Can anyone say where do we get that big volume of data? If I want to, any set of domain, if I want to do the analysis on student result, or if I want to do the analysis on any review, where do I get all this data? From internet. From internet, where is it okay that I'm just by clicking on the Google search and I'm going to take line by line of data and take it? Using data mining tool. Actually, after getting the data with the help of a tool, I can do the analysis. Where do I get the data first? Yes, UCI repository is correct. Srija, yours is right. Any other sources? Have you heard about data.gov.in? Indian government is having a one website, data.gov.in, and central, that is Central Government Women Forum. They are having their own repository to maintain all that. And if you want to do any analysis on a weather data, a few minimal set of weather data we can get it from the UCA. If you want to work on a real set of data, you can approach the Indian Meteorological Department. By reviewing your request, they'll be providing you the data, and you can go with the Google site. Or if you want to work only on a health data, you can have with the healthcare .com, the one site is there which is having the repository of data. In some places, this itself as a project, you can create a benchmark data. For example, I want to, if myself I'm taking any research and I'm collecting that data, I can create a repository for that. Even the data collection itself is going to be a huge project that you can do, and you can leave it for an open public. Such cases we can do. So these are all the places where you can get a data. The data.gov or the Kaggle website or the Google data set is there. The Google data itself is one of the site we can search for it and we can get it. So likewise, we can do it. Okay. By using all this, we can collect the data, after which we have to go on for the data mugging. That is making it to the uniform. We have to take into the common format, because all that are relevant to the requirement, we can confirm at veracity. The data what I have taken is required for me. The veracity is right, the value is right, but I have to make it as uniform. Because when we are talking about the value property, I said that I have to ensure the correctness of that value, whether that is really required to me or not. So even after it is required, I'm having it, but that may be in a different format. So make it as a common and make it as a uniform one. That is the second step. And we have to have it in the proper storage. Sometimes we can have it in a file format, or we can have it in a database. We can store it for a later usage. And some of the data we cannot make into the structured format. We have to have it in a unstructured format, for which we can use the other database like a MongoDB, RIS, Spark, which and all. The Spark, it is a one which is working as a, we can take that as a data warehouse, using which even without a query language also we can extract it with the help of mining tools. As the previous person told, right, the data mining tool can be used. Here only we can make use of the data mining tool. If your data is a structured one, we can go with the database, or for an unstructured one, we can go with the Hadoop file structure, or unstructured the databases which are all supporting for that unstructured data. So using some query languages or with the help of mining tools, we can take that for an analysis. So far in the data processing step, we collected the data, and we mugged the data. That is, we had made it as a uniform. Here, the one column may be having a unique number, other column having a roll number. So I can make that heading as a uniform. After which I have to have it in a common storage where I can have an access of all that. And the next step is exploring the data set. We have to analyze on that. The range of data. For example, I want to analyze the mark of the student, on one particular exam. The lower mark may be 40, the higher mark may be the 100. So I want to look into the variety. So how many of the students have fallen into the category of 40 to 50? How many had fallen to the category of 50 to 60? I have to have a study on that. So some basic exploration, okay? This is not going to be the final prediction about the performance of the student. It is the basic analysis we have to do. We have to understand the data. So how much it is going, for which just some of the data, just by looking into that, we can understand. But some of the data we have to visualize with the help of a graph. The initial analysis, the graph is not only to show the final outcome. The initial data itself can be plotted in the graph, and just by looking into that graph, we can identify what this data is, how this data is evaluated. We were talking about the sixth V, right? Can anyone say what is the sixth V we were talking about, the big data? Volume, variety, value, veracity, and one more V we discussed, right? I show you here. We're not able to recollect. See, variability, how far it is fluctuating. So these fluctuation you can identify with the help of plotting. Okay, that will be a very apt one just by visualizing it. Yeah, I got it in the chat. Yes, variability. Yes, thank you. Okay. So the variability. So just by looking into the graph, we can identify more instead of having the huge volume of data, because we are working on the big data. It is not a data with a one page of information. It is going to be a huge volume of data. So the plotting is the best methodology to analyze it. I show you an example over here. This is about the crop data, you can say, okay, the average crop production on one particular year. So here I'm having a plot for it. Is that graph visible to you all? Can anyone give one particular prediction or analysis by looking into that particular graph about this data? Can you able to identify anything from this graph just by looking into the graph of this crop detail? Is quantity variance. Each crop is having its own variation in the quantity. I'll give you the one input over here. See, in 2050, the crop one, it is having its gradual increase. It is not too much of fluctuation. Nowhere it is having its this particular year, this particular crop has given a high growth. This year, this is have given a less growth. It has been. That means that the agriculture department is constantly giving its input to increase the growth of or yield of this particular crop. And just by looking into that, look into the crop two. See here, in a 2016 onwards, the crop two, it is being gradually increasing, but in one particular point, it is having the high, one particular point, it is having a low like that. So those kind of analysis we can get, those kind of idea we can get by looking into the graph. As a computer science students, we may not be having much concentration on that. That's why all the computer science students are also insisted to do some mathematical and statistical learning. If you want to work on any data, you have to have minimal of statistical knowledge. Okay, so with that, we can analyze all these things. So the plotting is one methodology to understand the data. The next process is the pre-processing thing. In this, we have to have some, that is, we are saying though the variety of the value of data. Some of the data may not be right. Sometimes the data may be missing, or some cases one particular data may be having a huge change. For example, we are having a rain once in a while in Chennai. But that too, some of the year of rainfall is very huge, but it is not happening in all the time. So that particular data, we can call it as an extreme data, or it can be an outline data, because it is not a regular one. It is not always. But when you take a summer, always we are going to touch with the 40 degree of meter reading, right? It is going to happen always. In some year, if it is reaching 45, that is going to be an extreme one. That is going to be an outline. So likewise, the data may fall into extreme cases, or sometimes the data may be the missing one, and the normalizing process, because the scale of data may be different. I give you the one more example, which related to the data analysis of the result analysis. One college may be conducting the internal exam for a 25 marks. So their range of value falling under 1 to 25. The same other college may also conduct the CAA 1, but they may be conducting for 100 marks. So there the mark vary from 1 to 100. So, but both are CAA 1, both may be conducted for a 1 unit, but the range of value in a different range, the value in a different range. So we have to take into the normalized one. And we have to identify what are the fields required to do the analysis. The result data, I want to have a result or a mark of the student to know their performance. If the student is being allowed to participate in extracurricular activity, that is required. Nowhere their height or weight or their any other information like an address, all that is going to work on that analysis. So I have to identify the exact data which is valuable to that particular analysis that I have to pick. So all that you have to do in a pre-processing step. Okay, let me look into this one. See here, this is rainfall data, okay, which I have taken for, this is Indian average rainfall data I have taken from the Indian Meteorological Department. Yesterday only I took this, even though I got only till 2019. I took the latest years of data. So look into here, two information are being missed over here. For a January, February, for 2013, I'm not having a data. 2016 also, I'm not having a data. But I want to fill it. Some cases, the missing data can be omitted from the process. But some cases, we have to fill that. What can I fill in this place? Your inputs for it. There are a lot of methodologies to do that. That is a one big, vast area. But just to give you an idea, the missing data to be handled, I have taken this example over here. What can be filled over here? What data you can fill in this place? This place and this place, what you have to fill? I got one response and answer. NAN, that's what I'm saying, it is no. I cannot simply, it is not applicable. If it is of NAN, that have to be handled, because when you are passing this information to any of the processing through any programming language, if one is a numerical value, other one is a not applicable value. If NAN have to be filled with some value, or else I have to remove this entire row. If I'm taking this particular set of data for an evaluation, one is a numerical, other one is an NT, or other one may be NAN. That should not be. I have to fill it. Either I have to remove the data or I have to fill with some data. Zero or null. So is it okay that if I'm having a zero rainfall in that particular year? Is it okay? Because just look into the other data that every January month, if any of the January month is, if any January month is having a value near to zero, then I can fill this also as a zero, because there is a possibility that there may not be a rainfall in that particular year also. But look into that, in all the year, it is having minimum of 20 mm. Let us take, I haven't given the scale over here. It may be a 20 cm, okay? It is an average rainfall of Indian rainfall. So definitely it's going to be in a say cm only. So it is around the 20 centimeter. So we can take an average, or we can take a mean of it, or we can take a standard deviation on the nearby year's value. So in the 2019, this is the one, 2013, this may be the value. So somehow I have to fill it. So this is a one, this you can decide whether to omit it, or I have to fill with a zero, or I have to take it with an average, whichever is an applicable, that you have to do. That is a filling of data. And you look into the data, which is in a blue color over here. This is going to be an extreme, because average rainfall, which is being increased for 10 centimeter is huge, because when you look into the other year of data on the same period, it is having a range from 22 to 23 centimeter only, not more than that. But one particular year, it is going to be a huge. So from this, I can identify, because of this, which particular region of rainfall, the overall rainfall has been increased. That analysis I can do, whether that is a seashore area, whether it had a flood or not. So that extreme has to be identified. These are all the things you have to do in a pre-processing. So these are all the basic steps you have to take out for the pre-processing of data. As I'm having a volume of data, can I do all that in a single place? Because whatever I told, after collecting the data, I have to make it as a uniform, I have to make it as a structured one, I have to save this, I have to pre-process it, I have to look into the outline of a data, all that I have to do. But the volume of data which is in my hand is very, 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 very huge. How can I handle it? For which the Hadoop is a solution. The Hadoop is an open source platform which can handle this huge volume of data with the facility of distributed storage and the parallel processing. Do you know who developed this? Whose product is this? Yeah, I got one response. Facebook is using, okay. Yes, it's Apache Saya, that is right. It is Apache Hadoop. Okay, so this is open source software. You can freely make use of it. Even you can install in your system and you can configure your system to work on that. We are going to discuss further about its framework. What are the components available in that? Which component is responsible for a data? Which component is responsible for processing? Which component is to synchronize all that? Which component to monitor all that or to control all that? Okay, that is what we are going to discuss. So for which the main two thing is the runnable application is, we call it as a MapReduce. Okay, that is a major one in this particular one. And as I said, it is going to work on distributed parallel processing system. Okay. On the whole, this particular architecture is going to have four major components. The one is about the MapReduce. This is the one working on the process and the data. And when we are going about the data, that data have to be stored in a particular format that it is said to be a Hadoop distributed file structure. This is the distribution of the data. And in order to handle all that, in order to schedule a job, in order to distribute the data, and how to distribute the data, because I may not simply say that first 10 data is going to be in one part, second data is going to be in another part. Some systematic way I have to do. So for all which there is a utility, common JavaScript utility, Java utility, we can make use of that. And the next component is yet another resource framework. This is a job scheduling framework. I'm saying this data is in one part, other data is in another part. And I have to submit the process to work on the data. You find the average of these numbers. You find the average of these set of numbers. And at last, I have to combine all that. Okay. So the centralized part, the centralized component of Hadoop, which is going to take care of the job schedule. So all these and all exist. What I can do with this? Everything is there, right? In a Hadoop architecture, MapReduce is there, HDFC is there, YARN is there. What I'm going to do with that? As a computer science student, you can give your improvised contribution on any of this part. I am giving a better algorithm to do the distribution of the work. I'm giving a better algorithm to distribution of the data. I'm giving the better methodology to have a proper Hadoop distributed file structure. So you can give your own ideas and the proof for it. If that is being good, that can be taken into incorporated, because this is an open source. Because as in a Python, every day, every one of the person, those who are in a field are developing new algorithm, new programs, new packages, and later on that is coming into the use. If I'm finding one new method to handle a text file, so later on, I can say that particular programming code, line by line coding, I could have developed. I could have proved that mine is the best. So I can talk with that centralized person, that is Apache is the responsibility for that. If my work is highly proven, so that later on anyone can make use of that by including that in that open source. So because of that open source facility, you can give your contribution on any part of that. That's why still in that MapReduce, the research is not all going on. Let us see how this works. See, when we are talking about the data is going to be split in a such way that always in a form of multiples of bytes, 120 by 128 bytes or 512 bytes, like that. So based on the huge volume, the uniform distribution has to be done. We are not supposed to overload our data in a one particular place. When you are distributing the data, that has to be in a proper way, for which there is a node called name node that is in a Hadoop distributed file structure that is going to maintain a metadata. If I'm passing a 1 terabyte of data, that 1 terabyte of data has to be splitted uniformly. That has to be saved somewhere. That place, that is the chunked data, is going to be saved somewhere. That is called as a data node. That can be anywhere around in the world which is being connected to that, anywhere in the cloud or anywhere in the virtual system. The data can be located anywhere. So this may be in a distributed location. Even in your system, you can have a 10 data node, that is also allowed. If you are hiring some cloud storage, so your data can be in different location. So that is the data node. Your name node, if you are distributing the data in your place, the name node will be having an information which particular data exists in which particular data node. So that is going to be in a different place. Okay, so that is why the name node, that data, one client can have the data can be splitted in a different location. The data node can be in a different location like this. And even in that storage, when you are taking about the storage server, it will be in a rack. So in a different rack, it can be saved. And if you have to take care of that entire block of data, and we have to take care of these two concepts when the data is being traveled over the network, the fault tolerance and the speculative execution. More than one can have a handle of the single data that has to be taken care. If one data node is, if my system, I'm having a 10 data node, but if my system gets failed, I may not have an access to all that 10 data node which is having the data. See, if I'm passing one file, the file one can be passed. That file one can be splitted into multiple parts, because this may be in a terabyte. Okay, I cannot accommodate this particular entire data in a one place. So what this can be done is the name node will split the data and distribute the data among the data node which may exist in different locations. And it has to take care and it has to ensure that whether if any of that data node system gets failed, how can I recover that data? This is another area of vast research, okay? How to take up the backup. Because for that entire huge volume, I cannot take it out in a single place. The Syed, you have raised the question, how Hadoop different from the cloud storage? Okay, let me give you that option over here. When you take it as a cloud storage, the Hadoop, when you are going to incorporate in your system, it is in a single system, you can divide among the different node like that. And even the place, if you are hiring the storage from some other virtual system, then it is going to become a cloud. So in such a way, the data, the HDFC, that is a HDFS file system, that is a Hadoop distributed file system going to work on this. Your data is going to be splitted as a different part. Those different parts are in a different location, a distributed location. Okay, even if you have a multiple rack of storage in your system, you can configure your Hadoop and your own storage distributed system. Even if not, I'm not having a facility, I'm not having a revenue or a fund to buy the entire storage, then you can hire a storage from the cloud. Okay, both the ways are allowed. Okay, and when this is being done, it is going to work on in a key and value path. In such a way, the metadata will be saved. Okay. And how this HDFS, because we saw in the previous that the file has been distributed all around. Now we have to take that data for a processing. I'm having the data in a different location. I have to do some analysis on that. Even in distributed data, I like to do the analysis, or I want to normalize the data, or I want to fill the missing the data, or I want to find the outline of the data. All that I have to take up. That is a process I want to do, but my data is in different location. So that process you can write with the help of that mapper. Mapper is the one functionality exists in that Hadoop framework through which we can write the processing coding. The mapper function you can do these codings, the mapper and the reduce coding, whatever you are writing, that is exactly as the Java coding. Okay, so if you know the basics of Java, you can straight away write into this, because these are the inbuilt functions available for which you are writing your own coding, you are overloading that coding. So whatever the functionality you do for it, you want to complete, whatever the task you want to complete, you write that. So once after writing that code, when you're executing that code, during that, you will be specifying from which particular name node the data has to be taken, or which particular data node you are writing this particular process. That you will be specifying in a coding itself. Okay, for a startup students, you can look into that Apache Hadoop website itself. It is giving you the small set of coding that itself giving you the guideline to install the Hadoop framework in your system with a single name node. Why, even for a single Hadoop, you can have a multiple name node. If I'm running it 5 to 10 different projects, for all that project, there may be a different set of data. For each data set, I can have a different name node. One name node can divide the data into multiple data nodes. So initially, when you are going to in a startup level, you install that data, and with the guidance, you install it with a single name node configuration. Okay? So you work on that. By simple coding, we can take that data and we can run it. What that mapper will be doing is, it will take a data and it will work on that data. Usually it is not taking, it will be happening in a parallel processing only. So I'm having my work. I'm going to submit that work. That work is going to happen on a different data, which is available in different locations. After which I have to collect all the results, because I want to analyze the performance of college 1. I want to analyze the performance of college 2. I'm giving that analysis coding to them. They'll be doing the analysis. Both of them will be giving a result back. Then, and later on, I have to come into the conclusion, what is the performance of each college. That is what the reducer will do. Okay, from the data, the mapper is going to have a coding to complete some task. After completing the task, the mapper gives the result back to the reducer. So the reducer will be getting a result from multiple mapper. Okay, for if suppose if I'm having a data node 1, for that data node 1, I will be having a map function. Mapper will take a multiple map function. So that map function is the same process. Okay, this map function will work on the data node 1. There will be another data node 2. Data node 2 will be there. The same map. It is like someone said it is a cloned copy, right? The same way, this another map function will be taken, so that the same copy of process will be given to that particular data node, not to complete the same task. So likewise, the multiple map functionality is going to happen on different data node. Later on, that has to be collected in the reducer to come into the final conclusion. And where to save that result? Once again, I can depend on the Hadoop distributed file system, because that is a storage, that is the only component responsible for a data storage. The data which I want to process also have to be in this. After processing the data, the processed output also have to be saved somewhere. Then once again, with the help of HDFS, I will be saving that result back. This is the flow. So for entire data, the HDFS is responsible. For entire process, the map and reduce is responsible. All this will be coordinated with the help of YON. Can you all able to understand this flow? Thank you for your response. Here is another diagram which is giving you the detail of the discussion what we did in the previous slide. The data node, that is, it is having a multiple slide. This data node is being processed with the mapper. So mapper, it is going to have multiple map. That means the mapper is the process. The same process being given to the multiple unit, that is for the parallel processing, that we call it as a map. After which, from all the places, the reducer will be collecting the result, and the final result has to be saved. Okay, in order to understand this board, now I am going to give you the task. Okay, to your WhatsApp, I am going to share 3 text files. Okay, 3 text files I am going to share in a WhatsApp group where you are having a common place to do all your activity. You just look into that text file. It's a simple task. Okay, I want to have the number of all that files are having a numerical values. I want to have the count of each numerical value all together. I'm having file 1 that is having one set of numbers. The file 2 is also having another set of numbers, and the file 3 is having another set of numbers. Okay, I want to get a count of each number in file 1, file 2, file 3. And at later on, I want to put everything together. How many times the number 1 occurred all together? How many times the number 2 occurred all together? How many times the number 3 occurred all together? Okay, I'm going to share that data to your WhatsApp. That is a file. That is a plain text file. It is easy to access by all. Just look into that file. One of you can give the count of, one of you take a responsibility of one particular file, or whoever is working on the file, you can give your input on that. F1, F2, F3 or 3 files I sent in your WhatsApp. Just open that file. Whoever have completed that, the task is this one. That is my map work. I'm having a data in a 3 different. That is a 3 data nodes are there now. File 1, file 2, file 3 are 3 data node. That is a 3 set of data. Whoever is taking the file 1, they are the data node 1. Whoever is taking the say, file 2, they are all the data node 2. Whoever is taking the file 3, they are all the data node 3. My mapping work is give me a count of each numerical number in each file. Those who are completed can give your input. You people are the map now. You are doing your task. I have assigned you the map. Is file accessible to you all? Can you be able to access that file? Yes. Those who are completed F1, you can give your answer. How many times each number occurs in file 1? Syed, are you talking about a file 1? Okay. In F1, Syed gave a count that 100 occurs twice. And 22 times and 32 times, right? 33 times. Okay. And the file 3, I got an input that 21 times and 30 occurred twice and 41 times and 51 times, 101 times. Okay. Who's doing it for file 2? Yes, I got a response. Thank you. Yes, in that, yes, file 2, 100 for 2 times and 40 2 times and 31 times and 20 twice. Okay, so thank you all maps. Thanks for your process. Okay, all of you have completed your map work. Okay, your mapping process has been done. You have taken your data. The task assigned by the map is doing the count of each number. You have completed it. Now, each map will be sending the result to the reducer. This is a file 1 is being done by map 1, file 2 has been done by map 2, file 3 has been done by map 3. But as a result, I want to know the exact count by putting all the 3 files together. So for which the map will be doing 3 tasks. First, it will be doing the collection of all the results, and it will be doing the shuffling, and it will be doing the sorting. and it will come to the conclusion of it. So now all that data has been collected. That means all that has been collected and it is in a shuffled state. Nowhere it is being sorted. Okay, so what it will do is it will maintain as these values as a key and a value pair. All that result will be coming as what particular request, what will be the result. It may be something, okay, here I am saying it is a number. I want to find that the sales data of particular product. So the product may be the key, the sales data may be the value. So for each request, there will be a request name you can say, the request and the corresponding value. Likewise, it will be having a key and a value. So it has been collected as a key value pair. Now it is in a shuffled state. It has to sort it out. So in what way it can sort? Either it can do it in a ascending order or descending order. When you take it in a ascending order, the first one which comes is a 20. The second one comes is 30. The third one is 40. Key wise it is going to sort, okay? And it is going to take it as a 50. So that means it is not only taking the, it is going to take the 20 from F1 and the 20, if the 20 exists in F2, that also it is going to take. And if it is there, F3 also having a 20, it will take that also. Similarly, for all the key, it is going to take the value and it is going to sort here. And similarly for a 30 and 40 and 50. After which it is going to sum up with the sorting is over, right? The collection is over, shuffling is over. Now it has been sorted. What it is going to do is, it is from the file one, it has taken a key value pair of 20. All the values of that particular key will be summed up. So when it is taking the value from the 20, the 2 and 1. So for a 20 from F1, it is having 22, F2 it is having 2, and F3 it is having 1. By putting all together, it is going to take a value 5. So this is what going to happen in a Hadoop also. I'm having a data. I'm giving a task to be accomplished or task to be applied on that data. So the same task, I need to do it in a multiple place because the same data only I have stored in a different place. In all that location, I want to do the same task. So the same task is being in a form of map. All that maps are completing its task on the data and it is getting a result back. That result is being given in a reduced component of that Hadoop architecture. That reduce will collect all the data, it will shuffle the data, and it is going to sort according to the key value. And within a key, we can take it. Or even you can do some more analysis. Which particular data node is having more number of 20s? That also you can do. Okay, whatever for a reducer also you can have a task. From the result, you can derive any analysis. It does not mean that how many times this has been occurred. After taking that data, I want to predict which particular data node is having more volume of information. Let me take one more example in this. I want to do the analysis of, let me have that sales analysis of particular brand of fridge all around the world. This is a world-class company which is having the branch all around the world. It is selling the product through Amazon. I want to analyze which particular region of country is having more sales of that particular brand. So from each region, I have to take a high volume. In India, what is the highest total sales of that particular one? In China, how much it is? In Japan, how much it is? After collecting all that, I can come into conclusion which particular country, in which particular country this particular brand of refrigerator has been sold more. So I can sum it up. The total sales also I can take, or I can do different analysis. Okay, but the deriving of the data and sorting all the data according to the key and completing the task is the reducer work. The final result can be anything. So this is what the reducer and the map is doing. You, as a computer science student, as I told early, you can give your own contribution to enhance the Hadoop architecture, or with the help of this, you can have an efficient algorithm to analyze. That efficient algorithm you can write in a form of a map. Efficient algorithm you can write in a form of reduce. So this way also you can do. The Hadoop administrator is there. They will be doing the architecture based work. In such a way you can take your contribution, or else in a form of application analysis you can write a coding to complete this map and reduce task. Okay, this is the way the Hadoop architecture works in order to handle that big volume of data, which is having all that 6V of properties. Whatever the analysis you want to do, write that in a form of map and reduce, and you can accomplish it. So the number count, that's what we did here. I want to give an input over that. The latest version of the Hadoop architecture, that is 3.3.1. So here it is saying that you can have name node. I already told that. There is another feature called as channel node. For the name node, we can have one superior node, the channel node. So the latest version, it is allowing to have 2 channel nodes. For a one name node, which can handle multiple data node, you can have any number of name nodes for which you can maintain a channel node. Early it was only one channel node. But now with the new architecture, you can have 2 channel nodes also. So one channel node can be handling multiple name node. Name node will be handling a multiple data node. I have taken only minimal set of features which are all there. Whichever the topic I covered so far. For that, what is the latest enhancements exist? Apart from that, in all the architecture of the entire component of the Hadoop architecture is having more enhancement in the latest version. Okay, just look into that and you can take your research in what way you can give your contribution for this big data, either in a form of application through map and reduce or with the help of architectural based enhancement also. Okay, that's all from my end about the big data and how to handle that big data in a Hadoop architecture. If you have any queries, you can have. It is open to discussion.
If anybody have any queries, you can ask.
There are multiple fields, okay? The data collection itself, one part of research. After data collecting, you are doing the pre-processing. That pre-processing you are doing in a different places, a different location, okay? That itself is the contribution of Hadoop. So in all the stages of big data processing, you can do your research.
Hi, ma'am.
Yes.
Hello.
Yes, you're audible.
So I'd like to ask, how is big data different from data analysis and data science?
Okay, big data is not different from data analysis. They're also data, right? You're analyzing the data. For analysis, you are doing a systematic methodology. If that volume of data is more, then you can say it is a big data. Because of that huge volume of one, it is having its unique characteristic like the different variety, different structure, all that. But the data analysis and the data science is the base, it should be applicable for all. But as this is going to have a messy of content, we have to have some more methodology in the data analysis. That is why we are having a different algorithms for a data analysis part when the volume of data increases, because it is having a different property, right? The volume is different, the veracity is different, and the uniqueness of the value is going to be different, all that. So because of the different nature and the characteristics, the data analysis on the big data is going to have a different perspective on the different algorithm. But the analysis and the science should be there in all sort of data. So whether it may be a small volume or a huge volume.
Okay, so which one do you suggest I should get into, data analysis or a big data? Because both of them have are a vast field. They have subdivisions among them. For example, if you take up a course in big data, you can become a data architect or a data administrator and things like that. So which one do you suggest I should get into?
Okay, the big data, actually now you can directly concentrate on big data. You don't need to concentrate on small volume of data. You can straight away go into big data. When you say it is a big data administrator, they are going to work more on that HDFs, Because when you're taking that huge volume of data, you need a systematic methodology to distribute that. If I'm taking 1 terabyte of data, I have to decide on how many split up I have to do. In a 1 terabyte, do I need to split up as in a 1 GB, 1 GB, 1 GB like that? Or do I need to have in a MBs? Or if I'm going to take a cloud storage, I may not be having that cloud storage that is a uniform cloud storage. In all the places, I will not be getting a 1 terabyte. Then I have to have a split up in a different size. So all that comes into the data administrator, the big data administrator. They deals only about that, and they will be dealing about the other databases supported with the Hadoop. As I said, MongoDB, Spark, and the queries, the Hive queries, the Hadoop query structures and all there. No, they'll be working only on that. They'll be having the information. That metadata will be given to the map. So as a data administrator in the big data, you will be dealing about only the data. You will not be concentrating on a map. Such a way you can expand that. And if you want to become an analyzer, if you want to become a data analyzer, from that HDFS, you can do the analysis, for which you have to write a coding. As I said, right, what is the range of the data? What the normalization methodology I can apply on this to make it as a uniform one? In such a way, you can explore. So there are algorithms which is going to handle on that data pre-processing. The data analysis also comes from the pre-processing. And the one more analysis where you can do is after getting the result back from the reducer, because the reducer is having a collection of results. From that, you can do different sort of analysis. So as a data analyst, you can have your contribution on two places. One is before the actual processing in the pre-processing stage, for which you are taking the data from the data administrator and going to work. And the one more place is after getting the result from the reducer. There you will be writing more coding. It is whatever the coding you are writing that is being executed to get an analysis. So there's a two different batch, data administrator and as well as the other side of analysis part. Have you all heard about the database administrator? Database administrator. I'm Oracle administrator. I'm working as a SQL administrator. Have you heard of it?
Yes, ma'am.
Yeah, they are so much specialized on that. They know how to configure a table, how to share a table among a multiple user of that particular company. Because one particular table can be accessed by more number of software person in that. What are the log maintenance, who accessed on which particular time, which permission should I grant to which particular user, all that goes from the database administrator. Same for a big data administrator. There, instead of the database like an Oracle or that, here you are going to deal with the HDFS.
So does it simply mean that data analysis is more of a technical job?
Technical in the sense, data analysis, you have to have some statistical knowledge also.
I mean,
as a computer science
like
student,
more of coding.
Yeah, that is what nowadays one person posted a question about the Azure. Okay, I connect with over here. Azure is a tool for which you can supply a data, you can get some visual, or you can get some analysis report about the data. As you are an analyst, you have to give a report to your higher authority or whoever the client for whom you are working on. This much of sales has been done over here. So this sales has been affected because of this particular other feature, like today it was highly rained, so food supply is very less. So here the COVID affected region is more. This is a region where the more affected people are pointed out over this particular region. So that particular region had a high sales of food supply. So that relevanceness you have to analyze and give. Okay, so just by looking into the visual, you can do that part of analysis also there. Or else, in order to take that analysis, you can write a code. The Azure is a ready-made tool through which you can supply the data, or you can put your algorithm and you can take an analysis back. This is a one way of analysis. The other way is for an analysis, you can do the coding. I'm so much good in my logic. I can give any complicated problem I can deal. So in such case, you can give an analysis coding, because nowadays lot of algorithms are there, right? As you're a college students, I give you an example that the sorting algorithm you take. There are a lot of sorting algorithms. Why there are a lot more algorithms exist in that? Each one is having its own complexity. One is giving a quick result. One is taking a very less number of steps. So likewise, for an analysis, there are different set of algorithms. You can give your own contribution by giving your own logic to analyze that. If you are good on the coding, you can do that. Or by looking into the visual of the result, if you can give a result back, you can make use of the tools like that and give a result back. So in both the way, you can do the analysis. Does not mean that you have to good enough in the coding. Nowadays, market is going in a different way that means not a market. The IT field is going in a different way that there are a lot of tools are coming in a market that they are saying that no code or a low code. Even without a coding also you can accomplish with a very huge task, or with a minimal set of coding also you can do the task. So in a both the way it is possible. If you are good enough in a coding, you can do your own coding for an analysis, or if you are good enough in making use of the existing library, by using that you can do the analysis. Both the way you can become an analyzer.
Okay, ma'am. Thank you very much.
Thank you.
Thank you, ma'am. It was a really such an interesting and informative session. Participants, the feedback form link is in the chat box. Please fill the feedback form to receive your e-certificates. The thankful heart open our eyes to a multitude of blessings that continually surround us. I request Kunal to propose the vote of thanks.
Good evening, everyone gathered here. Respected resource person of the day, director ma'am, head of the department, teachers, and all the participants. It's my privilege to propose the vote of thanks. First and foremost, I would like to express my sincere gratitude to our resource person of the session, Dr. S. GOKILA ma'am, for taking time from her busy schedule and engaging with us in an interesting session. Thank you so much for your time and valuable information about big data and Hadoop framework. This session was very informative for all of us as we are all looking forward for a very successful corporate career. A special thanks to our respected director, Dr. Revati ma'am, and head of the department, Dr. Usha ma'am, for the immense support and conducting a very successful seminars. I also thank the organizing team for conducting a very successful sessions. I also thanks all the professors for their presence and support. I extend my support thanks to the participants for their involvement and presence of today. Once again, I thank everyone for your presence and for making this session successful. Participants, the feedback form link is in the chat box. Please fill the feedback form to receive your e-certificates. Thank you. Have a nice day.
Thank you, ma'am. Thank you. Thank you for.
And thank you for everyone for participating.
Yes, thank you.
Thank you so much.
With us.
Yeah, thank you. Thank you, all the participants. I thank the HOD of the department, the organizer, the director, the principal of the college for arranging such a wonderful thing. I appreciate all the participants, those who joined in this platform, because joining such a in a webinar or any guest lecture after your college hour is a very big matter. So thank you all. I appreciate your contributions in this. Thank you. Because
webinar. Thank you. Excellent session. Thank you, ma'am. Thank you.
Thank you all, sir. I'm leaving, sir. Thank you so much.
Thank you, ma'am. Thank you. Thank you.
So 5 minutes.